Today's lesson is on scientific notation, so make sure you title your notes and then write down the definition. It is a way to write numbers using powers of 10. You can think of it as a shortcut. If we have a fairly large number like 68,350,000, we can use scientific notation as a shortcut. If we have a very small number, now this is very small, it looks long, doesn't mean it's big, it is a very small number, we can use scientific notation as a shortcut. Before we start writing these numbers in scientific notation, you have to know the rules. So here are the rules for following scientific notation. You're going to have a number times 10 to a certain power. So this number right here, we're going to talk about the requirements in a minute. You're going to have a number there. Then it's times 10. This is a multiplication sign, not a variable. The 10 will never change. Now this exponent might change, but we'll talk about that in the next couple slides. Let's first talk about that first number. That first number has to be from 1 through 9. It cannot be smaller than 1. It cannot be larger than 9. The times 10 stays the same. And then the exponent can be any number, but sometimes you will see a positive exponent and sometimes you will see a negative exponent, which I'll explain further. So here we have the number 68,350,000. Let's write it in scientific notation. First, we have to determine how to get that number. We need a number that's from 1 through 9. Well, obviously 68,350,000 is not anywhere between 1 and 9. So we need to change the decimal point in order to make it smaller. Now, before we go changing the decimal point, let's talk about where the decimal point currently is, because right now I don't even see one. Whenever you do not see a decimal point, you can assume that it's at the end. So here's my decimal point right here at the end. We want to move it so that this number is now between 1 and 9. Well, if I keep moving it to the left, obviously these numbers are still bigger than 9. So, okay, here we have 6,835. That's still bigger than 9. 683, still bigger than 9. 68, still bigger than 9. 6.835. Okay, there we go. There's only a 6 in front of that decimal point. Doesn't matter what's after it. 6.835. The 6 is what we're looking at because that 6 is greater than 1 and smaller than 9. So that means that our number will be 6.835. I'm not getting rid of these other numbers. I'm just moving the decimal point. Now notice I did get rid of the zeros because the zeros were just placeholders. So if all you have left are zeros, then you don't need to write them. The next part of scientific notation will stay the same all the time. It's always going to be times 10. So that's easy. But now that exponent that's up here, we need to determine what that exponent should be. Well, that exponent tells you how many times you moved the decimal point, so that if somebody wanted to convert this back to standard notation, they would be able to do that just by counting. So here was our original decimal point. It was at the end. And here's where we moved our decimal point to between the 6 and the 8. So I'm going to count the spaces from here to the new decimal point. I'm counting every time I go between two numbers. So here's 1, 2, 3, 4, 5, 6, 7. So I moved 7 places to go from here to here. Now, should that 7 be a positive 7 or a negative 7? Well, the way to determine that is easy. If it's a large number, you're going to have a positive exponent, and if it's a small number, you're going to have a negative exponent. So since 68,350,000 was obviously a large number, that means that our exponent will be a positive 7. So these two things mean the same thing. This is what we call standard notation, which we'll get to in a minute, and this is scientific notation, which is what we were working on. Now, what if you have a very small number, like 0.00, whatever, tons of zeros there. It ends in 304. Again, we want to make sure that our number is anywhere from 1 through 9. So here's my decimal point right now. I want to move this decimal point so that the new number is between 0 and 9. Well, here I still have a 0 in front of the decimal, so that's still smaller than 1, still smaller than 1, still smaller than 1. Here, if I move it here, I know that I need to stop, because if I move it again, I'm going to have 30.4. That's too big. That's larger than 9. So I want to stop it here and put it between the 3 and the 0, because 3.04 is between 1 and 9. So my new number is 3.04. The next part is always the same. It's just times 10, but now we need to figure out the exponent, so we need to start counting. So here's where we started. We want to get to our new decimal point, so here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 places to move from our old decimal point to our new one. Now again, the question is, should it be a positive 10 or a negative 10? Since 0.000 whatever 304 is a very small number this time, we are going to have a negative exponent. So it will be 3 400 times 10 to the negative 10th power. Again, these two things mean the same exact thing. This is just easier than counting out all those zeros every time that you're trying to write that number out. Okay, now let's convert from scientific to standard. Well, what is standard notation? Make sure you write this down. Standard notation is just the number as we normally write it. Okay, so that's what we're used to every day, standard notation. So if I give you a number in scientific, 4 2/1000 times 10 to the 5th power, and I want you to write this in standard notation, you would simply have to move this decimal. So before I start moving the decimal, I've got to determine, well, is this a very large number or a very small number? Since my exponent is positive, it's going to be large. So what I'm going to do is I just write out the number, 4.002. And I know I want to move this decimal to the right because that will give me a larger number. So I'm moving it 5 places to the right. 1, 2, 3, 4, 5. That's where my new decimal point is. Now I've got 2 empty spaces here, so remember you're going to use zeros as your placeholders. So my new number is 400200. Decimal points at the end, but since it's at the end, you don't have to write it. But I do have to add in my commas. So remember, you start at the right and count 1, 2, 3 places, put a comma, 1, 2, 3. We don't need any more commas, so this number is 400,200. Mean the same thing. This is scientific, this is standard. And one more example, if we have 7 1,302 10 thousandths times 10 to the negative 7th power. Again, we're just changing this to standard notation. So look at our exponent. It is a negative 7. That means that I want a small number. So I'm writing this over to the right-hand side of the screen this time so that I can move my decimal to the left. I'm moving it 7 spaces to the left. 1, 2, 3, 4, 5, 6, 7. My new decimal point is here, and I fill all these with zeros. Now to be correct though, in front of the decimal you still need a placeholder there, so you do want to put another 0. So the answer here would be 0.00000071302. And again, these mean the same thing. This is scientific notation, this is standard notation. That's it for scientific notation. Bye guys.